Hello. Well, the other day we had a Kahoot in class. We had a lot of fun with this thing. It was in honor of Chris and his taunting of me on Instagram. The Kahoot covered questions from our entire school year in AP Calculus. Essentially, these were practice AP test, multiple choice questions. And the first time that you practice the entire semester, it can be humbling, especially when you're competing against your classmates and there's a time limit for each problem. So we found that we had some rusty spots that we need to clear up, but what I want to do is I want to run through solutions for each of these problems. I'll try and keep them as brief as possible so that I can recreate the time requirement for these questions on the Kahoot. But please give this entire video a look because it's going to be important as we move forward in practicing for that AP test. Okay, let's dive right in. The first problem says, what is the limit as h approaches 0 of cosine 3 pi over 2 plus h minus cosine 3 pi over 2 over h? The key to this problem is to recognize that this is a famous thing called the limit of a difference quotient, better known as the definition of derivative. The function that we're trying to find the derivative of is cosine of x, and the value that we're plugging into the derivative is 3 pi over 2. So to solve this thing, I just find the derivative of cosine x, which is negative sine of x, and I plug in 3 pi over 2, and then I do a little unit circle action here, and I whip around to 3 pi over 2. The sign down here is negative 1, but I'm doing the negative of that. That turns it into positive 1, and I'm selecting choice A. Piece of cake, right? All right, let's move on to the next one. For problem 2, we are asked, at which of the 5 points on the graph in the figure at the right are dy over dx and the second derivative both negative? So remember, when the first derivative is negative, that means your function is decreasing. When the second derivative is negative, that means your function is concave down. So we are looking for a section of the graph that looks something like this. And as you go through and check out these points, letter B should pop out to you as the point which fulfills both of those requirements. The function is decreasing there, and the shape is concave down. So I'm selecting letter B, which happens to be point B. Piece of cake, right? Let's move on to the next one. Okay. The slope of the tangent to the curve y cubed x plus y squared x squared equals 6 at 0.21. Well, notice this is an implicitly defined function, so I have to perform implicit differentiation to figure this bad boy out. So I'm going to start taking the derivative since we're on the clock here. This is going to be product rule first, so 3y squared dy dx. Whenever you do a derivative involving function y, you have to use the chain rule. Times x plus the derivative of x, which is 1, times 3y or times y cubed, plus we have another product rule here, 2y dy dx times x squared plus 2xy squared equals 0. And now wherever I see x, I'm going to put 2, and wherever I see y, I'm going to put 1, and then I'll solve for dy dx. Okay, so 3 times y squared would be 3, times 2, so that's 6. Let's erase that 3. This first thing here is 6 dy dx plus y cubed, which would be 1, plus 2 times y times x squared, so that's 8 dy dx, plus 2xy squared, so that's 4 equals 0. So we've got 14 dy dx equals negative 5. So that's going to be negative 5 over 14, which is letter C. All right, I almost hit the 2-minute mark on that one. Let's go on to the next one. For This problem, we're supposed to revolve region S around the line y equals 3. So, and keep an eye on this. We're in 0, 1. So let's just get a quick sketch of this and make sure we understand what's happening. We're on 0, 1, and then we're up here at 3. We've got a line, which is y equals 2x. So that line would go like this. When you plug in a 1, you get 2. When you plug in 0, you get 0. And then y equals 2x squared would start here at 0, 0, and then also hit the point 2, 1. But between 0 and 1, that parabola is below the line. So we're talking about this region here, and we are revolving that around y equals 3, right? So when you do the cross sections, they're going to be washers. The blue one will be on the inside, and the green one will be on the outside. All right, so we need the integral. For this volume, it's going to be pi. We're going from 0 to 1. It's going to be the big R squared, which is the green one. So that's going to be 3 minus 2x squared, minus the blue one, which would be 3 minus 2x squared dx. All right, I think I've got that right, so let's see which letter that is. That is going to be letter A, which is this one here. Okay. Right, it's a washer. We do pi times big R squared minus pi times little r squared. And I think we've got all the pieces here. The trick to this one is we're revolving up around the line y equals 3. So the parabola is actually the outside circle, not the inside circle. All right, moving on. Okay, which of the following statements about the function x to the fourth minus 2x cubed is true? And then you see we've got these 4 choices here. It's basically about extrema and inflection points. So what I'm going to do is a little background work right now, and I'm going to get the first and second derivative. So f prime of x is going to be 4x cubed minus 6x squared. Factoring that, it would be 2x squared times 2x minus 3. And then the second derivative is going to be 12x squared minus 12x. Factoring that, it would be 12x times, what is this, x minus 1. Okay? So I'm doing that work ahead of time so I can kind of see what's going on. Basically, we are going to have 2 critical points, right? We're going to have 0 and 3 over 2. And we're going to have potentially 2 inflection points, potentially, 0 and 1. If you're going to do this without a calculator, you better do a Sine diagram, 0, 3/2. This is my first derivative Sine diagram. And so just quickly looking at this, when I plug in something like 1, I'm going to get negative right here. When I plug in something like 2, I'm going to get positive. And when I plug in something like negative 1, I'm still going to get negative. So it looks to me like I have one extreme value. And then let's just do the second derivative here and see what we can figure out. I'm on 0 and 1. And so for the second derivative, if I plug in a negative number, this is a negative times negative, this is positive. If I plug in something like 1/2, I've got positive and negative, so that's negative. And if I plug in something like 2, I get positive, positive. So it looks to me like I have 2 inflection points. And so, what do we say? 1 extreme value and 2 inflection points. I'm pausing because I'm reading all these. I'm going with letter C on that one. But just to be sure, let's go ahead and check the graph and see how close I was. So here you can see I've just plotted the old graph here. And sure enough, we do have 1 extreme value down here, right? That's a minimum. and we do have a couple of inflection points. This thing changes concavity right here at 0, and it also changes concavity right here at 1, which is what my analysis showed. So you can do this problem with a graph pretty quickly just by looking at it, but you can also do it by hand by using your first and second derivative tests. Okay, let's move on. I'm going to try and make up some ground on this problem because all I have to do is find the derivative and plug in 0. So there's all kinds of chain rule going on in this problem. Be careful. But basically the derivative is going to go something like this. We've got the derivative of the squared part, which would be 2 sine of 3 minus x, times the derivative of the sine part, which would be cosine of 3 minus x, times the derivative of the 3 minus x, which would be negative 1. That all works out to be negative 2 sine of 3 minus x times cosine 3 minus x. And we are asked to find f prime of 0, so that's just going to be negative 2, I'll write it out here, negative 2 sine of 3 cosine of 3. And that is letter B right here. So that wasn't too bad. All right, let's move on to the next one. We're trying to find the average rate of change of the function f. Whoa, baby, I just knocked my computer over. Given that f is x to the fourth minus 5x on the closed interval 0, 3. So remember that the average value of a function, the average rate of change of a function is going to be given by basically the old school slope formula. So we need f of b minus f of a over b minus a. We're finding the slope of the secant line that connects those 2 points. So I'm going to plug 3 in, and f of 3 happens to be something like 66. And when I plug in 0, I get 0, and then divided by 3 minus 0. So this is just going to be, what, 22. Okay. And that's letter C right there. All right. That wasn't too bad. For this problem, the position of the particle moving along a line is given by s of t equals t cubed minus 24t squared plus 90t plus 7 for t is greater than 0. For what values of t is the speed of the particle increasing? So basically what we want to do on this problem is figure out the graph of the speed and then look for where it's increasing. A little quick reminder of how to get the speed. We need the velocity, and then we're going to take the derivative. We're going to take the derivative to get the velocity, and then we're going to take the absolute value to get the speed. So this derivative is 6t squared minus 48t plus 90. Okay, and actually we can do a little bit of legwork here. Basically, when we take the absolute value, we want to flip all the parts of the graph that are below the x-axis above the x-axis. Now, right now, we know this thing's a parabola because it's a quadratic. We just need to find out where it's below the x-axis. So I'm going to do it by hand to show you it's possible, but then we'll also just peek at the graph, and it'll be a lot faster that way. If I'm doing this with a graphing calculator, I simply graph the velocity, flip the parts up that are below the x-axis, and then pick out the answer. Okay, but let's see if we can locate where this thing is below the x-axis. Essentially, we need the zeros. So we're going to set t squared minus 48t plus 90 equal to 0. I notice quickly that I can factor out a 3 and maybe even a 6. Let's see. Yeah, we can take a 6 out. So let's go with t squared minus 8t plus 15 equals 0. And then, let's see, does that bad boy factor at all? 5 and 3 is 15. Yeah, so this is t minus 3 and t minus 5. So essentially we've got these two zeros. That means we cross the x-axis at 3 and 5. So when I'm analyzing this thing, I want to go with this velocity curve because the y-axis goes through here. Halfway between 3 and 5 is 4. So when it says for what values of t is the speed of the particle increasing, I'm talking about this piece right here and this piece right here. So from 3 to 4 and greater than 5. And that would be letter E. On the next slide, I've got the actual graph instead of my chicken scratch here, so you can kind of see that we have it correct. But if you're not allowed to use a calculator, you got to go through the algebra. All right, let's take a quick look. As you can see here, I graphed the speed, which is the absolute value of the velocity, and sure enough, we had it right. This thing is increasing from 3 to 4 and greater than 5. So enough of this problem. Let's move on to the next one. Okay. All right, we just have to do this indefinite integral. And my recommendation is that you distribute that square root of x and use the power rule. So this is going to turn into x to the 3/2 minus x to the 1/2 dx. And I'll just do antiderivatives. So the antiderivative of x to 3/2 is 2/5 x to the 5/2. And then the antiderivative for 1/2, that would be minus 2/3 x to the 3/2. Don't forget the doggone plus c, right? And then we just check out which one it is. It looks like letter D right there. Let's make sure. Yep, letter D. All right, good enough. Let's move on to the next one. So in this problem, we're just asked to find this limit. Way back in the fall, we worked with some algebraic techniques to find limits. When they're going to infinity, we have some rules. And one of those rules is if the degree of the polynomial on top is the same as the degree on bottom, we can just do the, ratio of the coefficients. So look, this is an x squared, the coefficient's 1. This is an x squared, the coefficient's -4. So right out of the gate, I'm picking -1/4 on this thing. You can also use L'Hopital's rule. You just have to run through the derivative a couple times. The first time you do the derivative, you get 2x over 1 minus 8x. And then the second time you do the derivative, you get 2 over -8, which of course is also -1/4. So you can do it either way, right, with L'Hopital's rule or with simply using our little rule by comparing the coefficients on the leading term. Realize that this polynomial down here is not written in descending order. So we just got to keep an eye on that. All right, let's move on. Okay, so we've got this region here, and we're supposed to find the area. And just by a little visual inspection of these two functions, I can see that the parabola is on top and the line is on bottom. So basically, I'm going to have to integrate 5x minus x squared minus 2x. The hard part about this problem is figuring out what the limits of integration are. So we know we've got 0, 0, so I'll put a 0 there. But what in the world is this point? Well, the fastest way to get that is to just set these two things equal to each other. So 2x equals 5x minus x squared. And this turns into x squared minus 3x equals 0. And so you can see the two places they cross are 0 and 3. So this number's got to be 3 right here. And then I'm going to quickly simplify this a little bit. This is the definite integral from 0 to 3 of, 3x minus x squared dx. The antiderivative is 3 over 2 x squared minus x cubed over 3. We're going to evaluate that from 0 to 3, or from 3 to 0. When you plug in 0, you're just going to get minus 0. So really all we have to do is plug in the 3. So I'm going to get 9 times 3 is 27 over 2 minus 27 over 3. And I just got to figure out what that equals. Well, 27 over 2 is 13.5. And 27 divided by 3 is 9. So this is just 4.5. And in terms of fractions, we got 9 over 2 right there. All right, so obviously if you just pop this into your calculator, you'd get 9 over 2 a lot faster than I did. But that's how you run through this problem. The key is to get those intersection points so you know what your limits of integration are. Moving on. So if y equals 5 plus the definite integral from 2 to 2x of e to the negative 2t dt, we're asked which of these is true. They all involve the derivative. So I recommend that the first thing we do is just go ahead and crank out the derivative of this thing. We're going to do this in two pieces. The first part of the derivative is pretty easy. It's just the derivative of 5, which we know is 0. The second part, we have to invoke the fundamental theorem of calculus, which basically says if you're doing a definite integral where there's a variable on the top limit, you simply plug that top function into the given function there. So this is going to be e to the negative 2x squared. And so this entire derivative is e to the negative 4x squared. So right away I'm crossing out letter A and letter B. The second part is a little more subtle. We are asked something about the initial condition. And what we mean is if we're plugging in this x value here, will we get the... Oh, I screwed up my derivative, didn't I? Shh, don't tell anybody. I'm going to keep going here. I won't redo it. You have to follow the chain rule. So after you plug it in, you also have to multiply by the derivative of 2x, which is 2. So the derivative is actually 2e to the negative 4x squared. If you were yelling at the video while I was doing that, I apologize for that. But what that means is we can cross out letter C also. So now we have to think about if I plug in 0 to this function, am I going to get 5 as the y value? Or if I plug in 1 to this function, am I going to get 5 for the y value? So remember, the function is simply 5 plus this definite integral. If I plug in a 0, then the top number becomes 0. And I've got this e to the negative t squared. I don't know why I switched to green, but dt. If I plug in 0, this is going to be 5 plus whatever the answer to that definite integral is. And it's clearly not going to be 0 because there is some area between 0 and 2 of this function. So I am not going to use this one. Check out what happens if you plug 1 in for the definite integral. If I plug 1 in, the bottom number is 2, and the top one is also 2. And it doesn't matter what's written here. This is a definite integral where a and b are equal, and so that's just 5 plus 0, which equals 5, and that's the one we want. Okay, so this slide was sort of an epic fail because of my derivative up here. I apologize for that. But we've settled in on letter E as our answer. And I think I recovered enough to convince you that that is the right one. Let's move on. Here, a particle travels along a straight line with a velocity given as 3e to the negative t over 2 times sine of 2t meters per second. What is the total distance in meters, total distance, traveled by the particle during the time interval 0 to 2? So when we measure total distance, we want to measure the places where this particle is traveling forward and where it's traveling backward. Absolute values. So we want to count all of that. That means we have to be careful with this velocity function. The parts that are below the x-axis, we're going to actually subtract instead of add so that we get the absolute values. Let me show you what I mean with a graph. Obviously, from the answers given to 3 decimal places, we're expected to use our calculator here. So graphing this thing is not a big deal. And notice that I do have a section of the area that's below the x-axis. So when you do this problem, you want to do the area here, which goes from 0 to pi over 2, plus the area here, which goes from pi over 2 to 2. So I'm writing down this total distance traveled, d, as the definite integral from 0 to pi over 2 of v of x minus this negative area, because we want to add the absolute value. The negative area would be pi over 2 to 2 of v of x. That's how you're going to type this thing in. And just either set up v of x ahead of time or just type in the function both times. And when you do that, here's what you get. This first definite integral is something like 2.0554, and the second one is something like 0.20593. And when we Add those together, it's like 2.261. And typically on the AP test, they have you round to the nearest thousandths, which is 3 decimal places. So we're talking about 2.61 on this problem. All right, that's enough of that one. Let's move on. I'll make up some time on this one because this one's fast. The graph of the function f shown above. If the limit as x approaches b exists and f is not continuous, which point is it? So I'm just going through and I'm looking for places on the graph where the limit exists, but the function value but the function is not continuous. And a quick little inspection here. I'm not continuous here, but the limit doesn't exist. I'm not continuous here, but the limit doesn't exist. Here's the place where I have the limit, right, is going to be 2, but the function is not continuous because the value is less than 2. So that's going to happen at x equals 0 or b equals 0, which is this guy right here. All right, that's enough of that one. Let's go to the next one. So this one's a little more complicated. Let f be the function such that the second derivative is less than 0 for all x in 1 to 2. What that's telling us is that the derivative, the first derivative, is decreasing. Keeping that in mind, we are asked to find out which of the following things must be true about f prime of 1.2. So we're zeroing in on this point right here, and we want to know something about the rate of change. The technique that you use to do this problem is simply to compute the slope to the left of 1.2 and the slope to the right of 1.2 so that we can estimate what's happening there. If I do 4.38 minus 4.18 over 1.2 minus 1.1 and compute that, you just get 2. Apparently I changed to yellow there. And then when you do 4.56 minus 4.38 over 1.3 minus 1.2, you get 1.8. And so we know that our slope is decreasing, and we know that it's trapped between these two values. So now I'm just going to look for the choice that illustrates that here. The derivative is not going to be less than 1.2, so we're going to cross out A. The derivative is not between 0 and 1.6. It's not between 1.6 and 1.8. It is between 1.8 and 2, right? And just to remind you what's happening here, we know that the derivative is decreasing because the second derivative is negative. And we've computed the slope to the left and to the right. To the left, we're at 2. To the right, we're at 1.8. We've got to be stuck in between those because this thing's always decreasing. So it can't go down and then come back up. Okay, that's enough of that problem. Let's move on again. Problems like this one often show up on the AP test. We're given a graph here. Notice they're all segments, as it says in the instructions. And we're asked if g is the function defined by the definite integral from 0 to f of t dt, what is g of negative 1? So the first thing we have to ask is, what kind of a function is g? Right? F is the function that's graphed, so what in the world is g? Since g is a definite integral of f, it's computing the area between the curve and the x-axis. So when this says g of negative 1, what we're really asking is, what is the answer to this definite integral, right? The area between the curve and the x-axis. Now notice these limits of integration are switched around. So typically what we really want to do is just do the opposite of the definite integral from negative 1 to 0 of f of t dt. Okay? And what that means is we want this area, and then we're going to make it negative. So you use a little geometry here. It's 1/2 base times height, so 1/2 times 1 times 2. That's just going to be 1, and we want the opposite, so our answer is negative 1, which is letter B. It's really important that you understand what a definite integral means to a graph. And we'll continue to work on that. All right, next problem. The graphs of 5 functions are shown below. Which function has a non-zero average value over negative pi to pi? So remember that the average value of a function is just the definite integral divided by b minus a. If the average value is 0, it means that the definite integral was 0, right? Because we're basically dividing by 2 pi, right? Pi minus negative pi. I'm drawing these little boundaries in so we can see what we're looking at. And remember, the definite integral just means area between the curve and the x-axis. So essentially, we're going to go through here and look at these areas. And notice the areas on top and bottom here are the same, so the definite integral is 0. 0 divided by 2 pi is 0. Same thing here. Nope, also 0. This one's a little tricky, but you can see these are still symmetric. So this one's also 0. And even here, it's not as easy to tell, but this one cancels out this one, and this one cancels out this one. So sure enough, we get 0. So this one's gone. Here, however, look, there's a lot more negative area, just by visual inspection, of course, than there is positive area. So I am choosing letter E on this one because that definite integral is going to be some non-zero value, and when you divide by 2 pi, that's still a non-zero value. It's important to remember what average value means. For us, the average value is the integral from a to b of f of x dx divided by b minus a. Just don't forget that when we talk about the average value of a function. Moving on. I love these problems. A differentiable function f has the property that f of 5 equals 3, f prime of 5 equals 4, and then we're asked what is the estimate for f of 4.8 using the local linear approximation, and we usually call this a linearization, at x equals 5. And when they tell you that, they're telling you that a equals 5. So you have to remember what we said about linearizations. We said L of x equals f of a plus f prime of a times x minus a. And this is basically the calculus version of the point-slope form for the equation of a line. So for us, our linearization, L of x, is going to be f of 5, which is 3, plus f prime of 5, which is 4, times x minus 5. And we want L of 4.8, right? So I'm simply going to do 3 plus 4 times 4.8 minus 5. And I'll just crank that out on my calculator and get the answer, which happens to be 2.2. And thank goodness it's on the list here. So that's choice A. All right, pretty good. Let's move on. So oil is leaking from a tanker at a rate of R of t equals 2,000 e to the negative 0.2 t gallons per hour. T is measured in hours. How much oil leaks out of the tanker from time t equals 0 to t equals 10? When we're measuring oil here, we're simply going to integrate the rate over the time period. So we're going to do the definite integral from 0 to 10 of 2,000 e to the negative 0.2 t dt. When you type it in, you'll use the letter x. But you just crank this thing out with your graphing calculator, and mine came out to be 8646.6, which is approximately, let's be official here, that's approximately 8647 gallons. And as you can see, that is letter D right here. All right, so we've got one left, and then we're done with this thing. I appreciate you hanging around to watch the whole thing. This problem is another one that we're going to need to use our calculator on. So we're told that the derivative of some function f is the sine of pi e to the x over 2. We're also given an initial condition, which is 0, 1, and we are asked to find f of 2. So we're going to use accumulation to write out a definition for f of x. if we know the derivative and we know an initial condition, then we can write out the definition for f of x. F of x is going to be that initial condition, which is 1, right, this guy right here, plus any accumulation after 1. So we'll do the definite integral from the x-coordinate 0, which is where the y value 1 is located, to some value x of sine of pi e to the x over 2 dx. I better make these t's, right? Usually when we write this, we change the letter here so we avoid confusion. So I'm going to put an e to the t here and a dt here. Okay, so we want f of 2, meaning that we're going to put a 2 where x is, not where t is. So we want f of 2. And essentially what you're going to do is just crank this calculation out in your calculator. 1 plus the definite integral from 0 to 2 of sine of t, sine of pi e to the t over 2 dt. Type that in on the calculator, and what do you get here? I come up with 1.157, which is letter E. Yes, we made it to the end. Thank you for listening. Expect more of this in the coming months here as we prepare for that AP test. For now, take care, and I'll talk to you soon.